Okay, so in this video we're looking at solving quadratics using estimation. Now up here you can see you've got x squared plus 4 is equal to 32. Now if you solve a quadratic or you solve anything, you want to find the missing variable. And the variable in this case is x. So you want to get the value of x to be something equal on its own. So let's begin by solving this equation. We've got x squared plus 4 equals to 32. Let's begin by doing the opposite of plus 4 and taking away 4 because we're trying to isolate the x to be on its own. So we're going to go and take away 4 here and take away 4 on the other side, our balance method. So these 4's up here are going to cancel, which is good. And you're going to be left with, on the left-hand side, you've got the x squared being equal to 32, take away 4, which is going to give you 28. Now you've got x squared equals 28. The opposite of squaring is to square root both sides. We can go and say that x is going to be equal to the square root of 28. And again, really you should be getting the plus and the minus of root 28, but just in this video, we're considering the positive square root, okay? Now, this is what we were doing last video. The square root of 28 is not going to give you a integer answer, a whole number answer. It will give you a decimal, which we can confirm on the calculator. If we go and type in the square root of 28, you're going to get some sort of non-terminating decimal. It's going to keep going on. So it's going to be equal to this here, 5.29. But we're trying to estimate the value of this, which is where what we did from last video comes into play. Okay, so now we've got to go and draw in our number line and say, well, what roots are between root 28? Well, we know that the square root of 25 is going to give you 5, okay, which is the lower sort of bound for root 28. And then 5, and then up here you're going to have 6. And then 6 times 6 gives you 36, so root 36 up here. And in between 5 and 6, halfway in between, you've got 5.5. And root 28 is much closer to root 25 than root 36. It's only 3 away, so it's going to be somewhere around about here, okay, root 28. So we can go and say, well, if this is 5 and that's 5.5, probably I'm going to say that that's going to be equal to 5.2. And we are estimating, so the way that you estimate might change a little bit. Okay, but we're saying here that by estimation, because we're not using an exact value here, we can say that the square root of 28 is approximately equal to, I'm going to say 5.2. Okay, but you might say 5.1 or maybe even 5.3. But for me, 5.2 is my answer. And I've estimated it again. This means approximately equal to 5.2. Okay, and that is my answer. And again, if we just look on a calculator, is that a good estimation? Yeah, it's not too bad, right? 5.2, you've got 5.29. So actually, if you put a 5.3, that's an even better estimation. Okay, 5.1, not so good, but also not horrific. Okay, so I would say probably 5.2 or 5.3 here is going to be a good estimation. So either of these answers is going to be good. Okay, so just a my turn, your turn. In fact, I'll leave them both on the board, on the screen, sorry, and you can pause the video and give those two a go. So solve the following quadratics using estimation. So we're getting approximate answers again here. Now again, you want to go and isolate the variable. You want to go and get x equal to something for both of these here. So let's begin by getting rid of this plus 7 by doing the opposite, by taking away 7 from both sides, then they cancel. So you're left over with x squared being equal to 18 take away 7, which is going to give you 11. And then, of course, to get x on its own, we square root both sides and we get the square root of 11. And the issue again here is the square root of 11 is going to give you a decimal answer. So you've got to go and draw a number line again and see where square root of 11 is going to go in between. So below root 11, you've got the square root of 9 because 3 times 3 gives you 9. And you've got up here the root of 16 because after 3, one above, you've got 4. Now in between, of course, you've got 3.5. And you've got the root of 11, which is much closer to root 9 because it's only 2 off and it's 5 off from root 16. So it's going to be closer towards 3. So it's going to be over this way somewhere. Now I would say, estimating for me, I'm going to say that root 11 is going to be approximately equal to, I'm going to say 3.2. Okay, but again, you might put 3.1, you might put 3.3, you might put 3.22. Okay, it's just, it is an estimation, so the value could change slightly as long as you're not estimating and it's miles off. But 3.2 looks pretty good to me. Okay, so that's my answer. And let's just see if this is roughly reasonable on our calculator. So if we go and refresh this and say we've got root 11 and see what we get, we're going to be getting 3.31. So yeah, not too bad, but actually a better answer here would be probably to estimate. But that's fine. Yeah, you get a mark on exam for that. But 3.3 is even better. Okay, and that is fine. Okay, so on to the your turn. Very, very similar. Again, you want to go and you're solving this, you want to go and find the missing variable. You want to get x on its own. And you've got x squared take away 4. Let's begin by adding 4 to both of these sides. Okay, to eliminate that minus 4, they cancel. And we're going to be getting x squared being equal to 23 add 4, which is 27. And of course, to get x on its own, we go and square root both sides, so we get the square root of 27. Now, the issue again here is root 27, you will not get a whole number answer. You're going to get a decimal, but root 27, we can go and put between root 25, which is equal to 5, and then root 36, which is going to be up here. Now, root 27 is much closer to root 25. It's only 2 away, isn't it? So I'm going to go and put root 27 over here. And I'm going to say probably 5.2, or it could be 5.1, or maybe even 5.3. Probably, I'm going to say approximately equal to between 5.1 and 5.2. Either of those answers are going to be valid. And again, let's just go and double check. On the calculator, if we go and clear this and put root 27, is that a good estimation? Let's have a look. So we're going to get this, but also 5.2. Yeah, so look, there you go. Pretty good. 5.2 is a really good estimation. Okay, that is it for solving quadratics using estimation. Hopefully that was useful, and thank you for watching.